Okay, number 6 here. For a molecule for us to judge it as polar or nonpolar, we need to know that there's a electronegativity difference in the atoms, and that's true for all of these. There's electronegativity difference, but it also depends on the molecular structure. And I'll draw these different molecular structures. So for NF3, okay, and each one of these NF bonds is polar, and they're all pointing in this direction. So this molecule at the end has a dipole, total dipole pointing down. So this one is definitely polar. CF4 has these 4 very polar CF bonds. However, it's a very symmetric structure. And so for that reason, all 4 of the individual little dipoles perfectly cancel each other out because this is such a highly symmetric structure. Now we have BF3, BRF3. Oh. Okay, lone pairs here and here, BF bonds, and because this top one and this bottom one can cancel each other out perfectly, however, this BRF bond, there's no other bond to cancel it out, and so this is most definitely a polar molecule. And then this final one, C, Cl2, F2. So there's a dipole, a big dipole this way, and a big dipole this way. Here, there's a tiny, and I'm showing that by making my arrow small down here, a tiny or smaller dipoles for the CCl bonds, and so at the end this doesn't cancel out, and so that molecule also is polar.